In the earlier session, we have discussed in detail about the process of physical weathering, which operates mostly in hot and cold, arid and semi-arid climate, whereas the role of temperature is very significant in weathering process. The temperature and rainfall are two major elements of weather. The question here is, do rainfall has any role to play in the weathering process? In what way rainfall or water helps weathering process? In which climatic condition it operates? Other than weather elements, are any other factors that aid weathering process, etc.? Keeping these queries in mind, the objectives set forth are to understand the process of chemical and biological weathering, to understand the geomorphic significance of weathering. Chemical weathering refers to the decaying and decomposition of the rock due to some chemical reactions in the rock. Due to chemical reaction, some of the primary minerals that are present in the rocks are converted into secondary minerals like carbonates and bicarbonates, which can be easily dissolved or removed from the rock. Decomposition of rocks due to chemical reactions is called as chemical weathering. The chemical reaction that undergoes in the rock is in the presence of water. Water is the main agent which activates several types of chemical reaction within the rock. Pure water is generally chemically inactive, but when it mixes with atmospheric gases, mainly carbon dioxide, becomes a potent solvent. The primary requirement for the chemical weathering is therefore the presence of water. Chemical weathering is seen mostly in humid climate where rainfall received is significant. Some rocks decompose when they come in contact with water and carbon dioxide from the air. Some minerals in rocks undergo chemical changes and they may be removed from the rocks, and thus the rock is weakened. Chemical weathering is brought in the rocks from 5 processes, which includes 1. Oxidation, 2. Carbonation, 3. Solution, 4. Hydration, 5th hydrolysis. Now oxidation. Oxidation is the chemical union of oxygen with some of the constituents of the rocks. Oxidation is more common in the iron bearing rocks. In the process of oxidation, oxygen dissolved in the water reacts with certain minerals, especially iron, to form oxides. Oxidation involves a combination of a mineral with oxygen to form oxides and hydroxides. Besides iron, other minerals most commonly involved in the process are manganese and sulfur. Due to the process of oxidation, the weathered surface of the rocks reveals yellow-brown layer or crust similar to rust. The rusting of the rocks weakens them and ultimately the rock is decomposed. The ferric oxides and hydroxides give brownish red or yellow color to the rock. In the oxidation process, the ferrous state of the iron changes into oxidized ferric state. Most of the iron bearing rocks commonly contains iron in ferrous state, like iron sulfide, that is pyrite, iron carbonate, that is siderite, and various iron silicates. This process is similar to the formation of layer of rust on iron objects. In the process of oxidation, rock decomposition occurs due to chemical reactions caused by the addition of oxygen. The oxidation of minerals of the rocks by gaseous oxygen becomes possible when oxygen is dissolved in water. Carbonation. In the carbonation process, the role of carbon dioxide is very important. Carbon dioxide from the atmosphere and the soil is mixed into the water, form diluted carbonic acid. Calcium carbonates and magnesium carbonates easily dissolved in carbonic acid and are removed in solution. Carbonation process helps in the breaking down of feldspar and carbonate minerals. Atmospheric carbon dioxide, after mixing with the rainwater, forms carbonic acid. Carbonic acid, after reacting with carbonate minerals like limestone, forms calcium bicarbonate, which is easily dissolved in water. Carbonation as a chemical weathering is common in karst topographic regions. Solution. Solution is considered as the initial step in the chemical decomposition of the rock. Solution refers to the dissolution of the soluble particles and minerals present in the rock. Solution of rock depends upon the nature and solubility of the rocks. Solution is one of the types of chemical weathering in which solid rocks are dissolved by the water. Solution as the process of chemical weathering has some significance in case of calcareous rocks. Of the minerals most vulnerable to solution activity are calcium, magnesium, potassium and sodium are the most important. Solution as chemical weathering process has some significance in case of calcareous rocks. When these rocks are acted by rainwater, becomes slightly acidic owing to its mixture with carbon dioxide from the atmosphere. Thus, solution is one of the processes responsible for the karst landform. The other main process being carbonation. Hydration. Hydration is the chemical addition of water into the rock. It is the process which is related to the addition of water to the minerals. The rocks, after having absorbed the water, undergoes changes in their volume. Minerals take up water and expand. When the rock absorbs water and when they are hydrated, the volume of the rock increases considerably. Thus, the increase in the volume of rock due to the increase in the volume of the minerals causes stresses and strain in the minerals of the rock, which ultimately leads to the decomposition of the rock. The increase in the volume of the minerals leads to the expansion of the rock. Hydration as a process that prepares mineral surfaces for further alteration by oxidation and carbonation. The process of hydration changes the rock like feldspar minerals into very soft kaolinite clays. Calcium sulfate absorbs water and turns into gypsum, which is more unstable and loose as compared to calcium sulfate. Many clay minerals swell and contract during the wetting and drying, and repetition of this process result in the cracking of the overlying minerals. Hydration is thus one of the major processes of chemical weathering, involving the addition of water to a mineral, causing it to expand and thereby initiate stress within the rock. Hydrolysis. Hydrolysis is the process in which both the mineral present in the rock and the water molecules decompose and react in such a way that new minerals compounds are formed. Hydrolysis is the chemical reaction between mineral present in the rock and the water, that is between hydrogen ions or hydroxyl ions, that is OH ions, and the ions of the minerals. In a hydrolysis process, hydrogen from the water combines with certain ions from the minerals to form different chemical compounds. Hydration is a process in which water is simply absorbed, whereas hydrolysis process involves active participation of water in the chemical reactions to produce different set of minerals. The physical and the chemical weathering in general are inseparable. They are complementary and supplementary to each other. Mechanical fracturing or disintegration of the rock increases the surface area where chemical action takes place and permits deeper penetration for chemical decomposition. Chemical decay in turn facilitates mechanical disintegration. One of the weathering process may dominate in a given area depending on the climate and rock composition. Mechanical and chemical weathering process may attack the rock at the same time. Biological weathering is the disintegration or decomposition of the rock due to biological agents. Plant and animals, including man, largely influence the weathering process. Biological weathering refers to the decomposition and disintegration of the rock due to organic material of both plants and animals. Production of different kinds of organic acids such as humic acid, microfaunal acids, etc., produced by the organic materials helps in the decomposition and disintegration of the rock. Plants assist in surface weathering by both chemical and mechanical means. Algae, mosses, lichens and vegetation retain water on the surface of the rock. Various organic acids helps to decay the rock beneath. Burrowing animals like prairie dogs, foxes, rabbits, jackals, etc. ducks out and burrows in the rock and removes the unconsolidated material as their living places. Due to the removal of the unconsolidated material like soil, the underlying rock is exposed to the weathering process. Burrowing animals helps to loosen the surface material. Chelation is a form of chemical weathering by plants. The presence of vegetation increases acid content of the soil water. Humic acid activate chelation process and help in the decomposition of the silicate minerals. Bacterial acids including lactic, acetic and oxalic acids attack wide range of rock minerals like magnesium, carbonate, calcium, silicates. Presence of moisture also increases bacterial activity and it assists the decomposition of some rocks. It is an effective medium of chemical disintegration of calcareous rocks. Presence of moisture also increases bacterial activity and it assists the decomposition of certain rocks. Vegetative cover generally protects the rock from being exposed to the weathering process. Dense canopy of vegetation may actually prevent the weathering process. Removal of the vegetation is responsible for the acceleration of weathering process. In case of mechanical disintegration, effect of the vegetation is mainly due to the penetration and expanding capacity of the roots that exerts considerable force as they grow and help to widen the crack and crevices present in the rock. Man, being a biological agent, accelerates the natural rates of weathering by many folds. Today, technological man has become the most important weathering agent. Mining activities for the extraction of minerals, leveling down of the hills by blasting, quarrying and industrial and building materials, etc. results in accelerated rate of disintegration of the rock. This may be accomplished by natural weathering process in thousands of years. Man accelerates weathering on the hill slopes by modifying the ground surface through deforestation, which increases slope instability, which causes slope failures and mass movement of the materials down the slope in the form of landslides, slumping, etc. Geomorphic significance of weathering will be considered under 4 headings: as an aid to mass wasting and erosion, as a factor in general lowering of the height of the land surface, to the creation and modification of landforms, as a major process in the formation of regolith and soil. Weathering is a major natural factor which has great significance in the production of rock waste or soil as a supplementary agent of erosion. as a process of denudation. As a factor of landform evolution, rocks are disintegrated and decomposed and ultimately are broken down into smaller pieces due to the operation of different weathering processes such as mechanical weathering, chemical weathering and biological weathering. Thus, different weathering processes produce volume of rock waste of weathered material. The weathered material lying over the unweathered bedrock are called as regolith. The depth of the weathered rocks from the ground surface to the unweathered bedrock is called as weathering zone. The depth of weathering zone varies from place to place and region to region, depending mainly on the depth of water table or groundwater and duration of weathering. The end product of weathering is soil formation. Weathering generates mass movement of rock waste down the slope, which causes damage to human settlements in the foothills region, causes obstruction in the river flow. Weathering helps erosional processes. Both weathering and erosion are agents of denudation. Weathering loosens the rock by disintegration and decomposition of them, thus paving the way for erosional processes to operate easily. Different agents of erosion like running water in humid region, wind in hot and arid and semi-arid regions, glaciers in cold regions, sea waves operating along the coastal zones obtains the weathered material, and these weathered material will act as cutting or erosive tools. Continuous weathering and removal of the material through different processes results in the translocation of rock waste or weathered material in the form of debris slide, rock fall, landslides and talus creep, etc. along with the agents of erosion, causes gradual lowering of the height of the affected area. Weathering helps in the evolution of various landforms. Differential weathering helps in the evolution of different types of landforms. Weathering pits are common on limestone and often resemble potholes produced by aberration. Different types of weathering are specifically potent in different type of climatic regions. The effect of weathering upon the rock varies according to the capability of different climatic elements. In equatorial region, where humidity, temperature and rainfall are high, both chemical and biological weathering is very active and effective process. Tropical climates is generally characterized by alternate wet and dry season. During the dry season, evaporation is very potent, but the wet season is characterized by seasonally excessive rainfall. Chemical weathering is common in humid tropical areas because of more availability of water and high temperature. Leaching process is very common in tropical humid climate. The fine particles of silica, which acts as binding agent, is leached or removed from the rock due to rainwater. Due to leaching of fine particles of silica, the rock develops cavities. Such type of weathering is called as honeycomb weathering. Due to leaching process, laterites are formed. Such rocks are rich in oxides of iron and aluminum or bauxite. In tropical climate, rocks are subjected to mechanical weathering during hot and dry season months. Tropical hot dry climate, arid and semi-arid climate, or in desert areas, chemical weathering is more or less negligible. Mechanical or physical weathering is most predominant type of weathering in this climate. During the dry season, water is drawn to the surface through the capillary action, leaving behind a hard compact layer known as dewy crust. This is common in semi-arid climates with short rainy season. Rocks in the dry climate are more susceptible to mechanical than chemical weathering. In the mid and high latitude, or temperate and subpolar climate, the role of frost is very significant. Mechanical or physical weathering is common in the form of frost wedging, which is a type of mechanical weathering. In cold climate like polar climate, both mechanical or chemical weathering cease to exist when the ground surface is covered by permanent ice sheets. Chemical decomposition of the rocks may be effective provided the ground surface is not covered by ice cover for a longer duration in the year. The surface of the earth or the portion of the earth's crust has underground exposure to the weathering process is known as zone of weathering. Depending on the climatic conditions and the rock formation, it varies greatly in thickness. In tropical and subtropical regions, it may extend greater depths. In northeast India, in the Khasi and Jaintia hills of Meghalaya, weathered rocks up to a depth of 40 meters are found. The interface of zone between weathered and unweathered rocks has been termed as weathering front. Weathering is a denudation process which operates universally under all climatic conditions. Chemical weathering operates mostly in humid climate, whereas the role of water is very significant in the decomposition of the rock. Various chemical weathering processes like oxidation, carbonation, solution, hydration, etc. acts on the rock to decompose, dissolve or reduce them. Water along with oxygen and carbon dioxide brings about chemical reactions on various minerals present in the rock, which helps in chemical weathering process. Plant and burrowing animals also are the factors in the weathering process in the form of biological weathering. Today, man has emerged as the most important weathering agent. The end product of weathering is soil and the rock vest. In the subsequent chapters, we will be discussing about mass vesting and erosion, where the role of product of weathering in the form of rock vest is very significant.